Somewhere on this screen, there's a snake hidden in a pile of flowers. You already found it, didn't you? Almost instantly, before you finished reading this sentence. Now flip it around. One flower, hidden in a pile of snakes. Slower. Your eyes have to crawl across the screen and hunt for it. That gap, the speed of finding the snake versus finding the flower, is not random. It has been measured in a lab. When psychologists build exactly these grids and time people with a stopwatch, the snake jumps out almost the instant the image appears, while the flower makes your gaze wander. Your brain is running a search engine that was tuned over millions of years to do one thing faster than almost anything else in the visual world: find the snake. So why are you this good at it? And why does a curl of rope on the floor, or a garden hose in the grass, snap your attention and put a jolt in your chest before you can even think the word snake? The answer goes back about 60 million years, and it ends with a twist that almost everyone gets wrong. Start with the threat. Long before there were big cats, before wolves, before any of the predators we usually picture hunting our ancestors, there were snakes. When the first small mammals were scurrying around in the dark at the feet of dinosaurs, snakes were already there, eating them. This is the key thing to hold on to. The snake was not one danger among many. It was the first. Constrictors came earliest, squeezing the life out of anything they could wrap around. Then, tens of millions of years later, a second wave evolved a new weapon: venom. Now the snake didn't even have to hold you. A touch could be enough. For our tiny tree-dwelling ancestors, a snake was not an occasional danger. It was the oldest danger, the one that had been there the entire time, changing its methods, staying a step ahead. And here is what made it so different from every other predator. A lion charges, a hawk dives. You can see them coming, and if you're fast enough, you can run. A snake does none of that. It waits, motionless, camouflaged, coiled in the exact colors of the leaves around it. It does not hunt you across the open. It lets you walk into it. Against a predator like that, speed is useless. The only thing that saves you is seeing it first. In 2006, an anthropologist named Lynn Isbell put forward an idea that sounds backwards at first. She argued that snakes didn't just frighten our ancestors. They helped build our eyes. It's called the snake detection theory. The logic goes like this. The primates who survived weren't the fastest. They were the ones who could spot a still, hidden shape a half second before they stepped on it. And over millions of years, that pressure favored sharper, forward-facing eyes with overlapping fields of view, richer color vision to break a snake's camouflage, and specialized wiring deep in the brain, all tuned to pull one shape out of a messy, cluttered, leafy background. In this telling, the sharp, detailed vision you are using to read these words was paid for, in part, by ancestors who had to find snakes. Here's the strange piece of evidence that holds it up. On the island of Madagascar, there are primates called lemurs. Madagascar broke away before venomous snakes ever arrived. So lemurs evolved in a world with almost no deadly snakes. It's a natural experiment nobody had to set up. Take one group of primates, raise them for millions of years surrounded by snakes. Take another and give them none. And the lemurs, the ones who never needed to spot a hidden killer, have noticeably poorer vision than the primates that grew up dodging them. The primates that lived with snakes are the ones that ended up seeing the best. Take the snakes away, and the eyes never sharpen. Then in 2013, a team including Isbell, led by a researcher named Quan Van Lay, went looking for the alarm itself. They recorded single neurons in the pulvinar, a deep and ancient part of the visual brain. The pulvinar isn't where you consciously see. It's part of a faster, older route, the one that reacts to something before the thinking part of your brain has even registered what it is. And they were recording it in macaque monkeys that had been raised in a lab and had never seen a snake in their lives. They showed these monkeys images, faces of other monkeys, hands, geometric shapes, and snakes. The neurons fired fastest and hardest for the snakes, not for the faces of their own kind, not for anything else. For a creature they had never met, there was already a dedicated set of cells, firing in milliseconds, waiting. And it shows up in you early. Back to that snake in the grass. When psychologists run the grid test on 3-year-olds, they do the same thing adults do. They find the snake fast. The detector is installed long before anyone teaches a child a single fact about snakes. So here's where almost everyone assumes the obvious. We must be born terrified. We're not. This is the part the memes get wrong. And it's the most interesting part of the whole story. When researchers showed snakes to 9 and 10-month-old babies, the babies didn't panic. Their hearts didn't race. They just looked calmly and for a long time. What those infants had was not fear. It was attention. They locked onto the snake faster than other things. But the dread simply wasn't there yet. The alarm was pointing at the snake. It just hadn't been armed. What you're actually born with is something psychologists call prepared learning, not the fear. The readiness to learn the fear instantly from almost nothing. You can see it cleanly in monkeys. A lab-raised monkey that has never seen a snake isn't afraid of one. But show it a single video of another monkey reacting with fear to a snake, and it learns that fear almost immediately and keeps it for life. Now here's the catch. Show that same monkey a video of another monkey panicking at a flower or a rabbit, and nothing sticks. It cannot learn to fear the flower, no matter how many times you show it. The slot is pre-cut, and only certain shapes fit. That's the real design, and once you see it, it's hard to unsee. Think about the math your ancestors faced. If learning to fear a snake took 10 bad encounters, the ones relying on that strategy did not survive to have children, because a bad encounter with a snake usually meant there was no second encounter. They got one lesson if they were lucky. So evolution solved it in the only way that works. It didn't hand you the fear, ready-made, because a baby terrified of everything can't function. Instead, it handed you the radar, always on, and next to it a hair trigger primed to load the fear the very first time the world shows you or even just shows someone near you. Why? To be fair, this is still an argued idea. Not every scientist agrees that snakes alone reshaped the primate eye, and the full story is still being worked out. There are other pressures that shaped how we see, but strip the debate down to what has actually been measured: the speed of detection, the neurons in the pulvinar, the toddlers finding the snake, the monkeys learning in a single trial, and that part is not a guess. It is real, and it is sitting inside you right now, which leaves you here, in a city, behind glass, scrolling a screen where nothing is going to bite you. And still, a coiled garden hose at the edge of your vision grabs you before you can think. A crack in the pavement, a stick on the trail, a shadow that isn't quite a shadow. For a fraction of a second, an alarm older than the human species fires, runs its check, and stands down again before you even notice it ran. It has done this, quietly, thousands of times in your life, and you have almost never caught it in the act. You're not scared of snakes because you're weak or irrational. You're scared of them because, for 60 million years, the ones who weren't didn't live long enough to become anybody's ancestor. The radar is still switched on. It's just sitting in a world that mostly doesn't need it anymore. You're more ancient than you think.